So today we're talking about the law of conservation of mass. So according to the law of conservation of mass, matter cannot be created or destroyed. In a chemical reaction, atoms are rearranged to form a new substance. Therefore, the mass of the reactants must equal the mass of the products. So when we talk about a chemical reaction, remember we said it's represented by a chemical equation. So according to this law, what we start with has to match what we end with. So we're going to see if that's actually true. So if we look at our example here, we have a chemical equation in which methane reacts with 2 oxygen molecules to yield or produce carbon dioxide and 2 water molecules. So I want to see if we actually are using the same atoms and rearranging them. So let's take a look using Legos. So I'm going to use a yellow Lego to represent carbon. I'm going to use green to represent hydrogen and blue to represent oxygen. So let's build our first molecule. So I have carbon 1, hydrogen 4. So I'm going to take my carbon and I'm going to bond 4 hydrogen atoms to this. Now you notice I'm putting them actually together. The reason I'm doing that, that represents the bond where they've joined. See, these are chemically bonded. Now O2, that means I have 2 oxygens. So take 2 blue, bond them together. But you see I have this big 2 in front. That's a coefficient and it tells me I have 2 molecules. So I have to actually do this again and represent 2 molecules. So looking at my equation, I have my methane and I have my oxygen molecules. So these are my reactants. All right. Now let's take a look at our products. So I should be able to produce a carbon dioxide molecule and 2 water molecules out of the same atoms. So during a chemical reaction, these bonds are broken. So we're going to take these apart because they're going to no longer be bonded together during this reaction. They're mixed up and create a new substance. So let's see if using these same atoms I can construct carbon dioxide and 2 water molecules. So here's my carbon. It takes 2 oxygens. Here's carbon dioxide. Water, H2O, 1 oxygen with 2 hydrogens. Now again I have a 2, so I need to make a second molecule. So now in my products, so if we look, this is my product side. We have carbon dioxide and we have 2 water molecules. Now you see that I was able to use the same atoms, rearrange them to form a new substance. I didn't create any more atoms and I didn't destroy or lose any atoms during this chemical reaction. So is it true that the mass of the reactants equals the mass of the products? So let's find out. So the way we're going to do that, I want to look at the actual mass, and I'm just going to use the mass off of the periodic table. So if we look at that mass, we have carbon has a mass of 12, hydrogen has a mass of 1, and oxygen has a mass of 16. So based on these numbers of atoms, we're going to calculate and see if they're the same. So on my reactant side, I had 1 carbon, so I'm looking at a mass of 12. I had 4 hydrogens. Each hydrogen has a mass of 1. I have 4 oxygens. Each oxygen has a mass of 16. If I add these up, we get a total of 80. Now let's compare this to our product side. Carbon, I have 12. Hydrogen, I have 4. And oxygen, I have mass of 16 times 4. Total is 80 grams. So if we look in this scenario, my mass of the reactants is equal to the mass of my products. So in this equation and in this chemical reaction, we have followed the law of conservation of mass. My atoms in the beginning match my atoms in the end. My mass of reactants equals my mass of my products. So in our chemistry IMB, we have another scenario. If we look at the bottom, you see you had calcium chloride reacting with sodium sulfate. You end up with a mass in the beginning of 300.23 grams. You have the reaction taking place, and then in our products, you notice we have totally different compounds, CaSO4 and NaCl. That's not what we started with, but it is the same atoms. And we ended with the same mass of 300.23. So remember, the law of conservation of mass states that mass cannot be lost or gained during a chemical reaction. So the atoms at the beginning must equal the atoms at the end. So reactants equal the products.